In this video, I'm going to have a look and I'm going to tear down the most cheapest 240 volt LED bulb from cdrking. This only costs about 0.8 USD or 38 PHP. So it says 3 watts but I'm sure it does not consume 3 watts. Unfortunately, I don't have an AC wattmeter to prove it to you. Nevertheless, it's bright and quite acceptable. This brightness is quite good for a table lamp. If you watched my previous video, this is actually where the LEDs came from. It's very easy to open because it's plastic. The purpose of this plastic lens is to scatter and diffuse the light coming from the LED. Now, there are 5 rectangular SMD LEDs and it's just soldered in this white circuit board. It's just locked here and this is the back part of it. There are no heatsink, only capacitors. There's a metal film capacitor which is non-polarized and electrolytic which is polarized. So this is the circuit. It's quite simple. First, this is the 240 volts RMS mains, and then the current flows through this capacitor. Because a capacitor has a reactance, it resists the flow of AC current. So the voltage here will be much lesser. And the AC voltage will be rectified in the bridge rectifier. So we have DC here and capacitor for filtering. The LEDs are in series and through this resistor for some current regulation. And that's basically how it works. And you can simulate this on the Every Circuit app. Link is in the description. So let's measure the forward voltage drop of this small white LED. And it's 3.1 volts. 5 of them in series need 15.5 volts to operate, but after 5 minutes, the voltage drops to this. Because the resistor gets hot, the screw regulates the current. And the voltage drop of this SMD resistor is about 3.32 volts. To get the power loss, V squared divided by R equals to 234.5 milliwatt. That's quite acceptable. And this is the current and voltage after the bridge rectifier. So we can get the power consumption. At the initial, the power is only 1.4 watts. After some time, the power goes down to 1.36 watts. As you can observe, the current is quite constant. That's nice because an LED needs a constant current. However, I have one of these and used it for 2 years. I observed that the brightness is decreasing. And I think this is the primary disadvantage because of this metal film capacitor. The equivalent series resistance of this capacitor increases, so less current can pass. It heats up and burns itself. It explodes. Like this washing machine capacitor, it explodes after several years of use. Anyway, it's not that expensive. In the end, it's better to use this SMPS supply to power LEDs because it's efficient and more reliable. If you like this video, please hit like, share, and subscribe. And remember, be innovative.